Insertion sort is another sorting algorithm, and it performs better than the bubble sort because it performs fewer comparisons / loops. It sorts the data into a list into alphabetical or numerical order by placing each item in turn in the correct position in a sorted list. It works well for incremental sorting where we are adding elements to a list over time or extended period while keeping the list sorted. Here's the reference for the syllabus, Computer Science A-Level 9680, right? Here, 9.1 algorithms show understanding of insertion sort and bubble sort. Write an algorithm to implement insertion sort. Okay, so before going over the pseudocode, I'll explain what actually happens. So in insertion sort, we select the second element in the array, or we start with the lower bound plus 1, or the element in lower bound plus 1. So here we start with 6, and then we compare 6 with the element that was before it, so 47 here, and it happens to be less than 47, so it moves up. Essentially what we're doing here is that we partition the list into two sections when we select lower bound plus 1, and the left of this, or below lower bound plus 1, is the sorted list rather, and after this is after this whole part is the unsorted list. So we loop through this part of the array and compare it with the previous values. That way we sort backwards, if that makes sense. So I'll explain what happens here. So we compared 6 with 47, right? And we knew that 6 was less, so it went up. Now we're going to look at 47, or rather 54, not 47, because we were at 1, right? Lower bound plus 1, and then we increase. So we go to 2. So now we have 54. 54 compared with 47, it is greater, so nothing happens, no swaps. And now 17. 17 is less than 54, it goes up. But because I told you that we go through whole of the sorted list, so we'll keep decrementing and checking until 17 falls in the right place. So 17 compared with 54, we knew that it would go up, but then 17 compared with 47, it's again less, so again it will go up. And now it's in a correct position. Moving on to 93. 93 is greater than 54, so 93 stays in its place. Now 28. 28 is greater than 93, it moves up. 28 is greater than 54, it again will move up. 28, or rather less than 93 and less than 54, my bad. And then 28 is less than 47, so again it will move up. Now 28 is greater than 17, so it stays in its place, which is here. And now we have the whole list sorted. Now let us look at the pseudocode for insertion sort. First, I'll go over the identifiers. So my list is the array to be searched, and it has 9 places, 0 to 8, right? Upper bound will be 8, this is the upper bound of the array. Lower bound is just the lower bound. Index is what we use to loop through the array, and key is the element being placed, and place is the position of the array being moved. Now this will make sense when these last two especially would make sense when we go to the code. So we declare all those variables, and we set our upper bounds and lower bounds. We have declared the variables, the array, the upper bound and lower bound, the index, and key and place. So the upper bound is 8, the lower bound is 0, because it went from 0 to 8. And now we'll begin looping through the array. But like I said, or I explained earlier, we start with the second array, second element of the list, not the first, because we'll be comparing backwards. So if we had like 9 in the first and 8 in the second element, if we start with the first or the first element in the array, or the lower bound, then when we compare backwards, we'll be comparing with -1, or basically we'll be getting an out of bounds error, because we'll be comparing in a place, in a position that the array does not have. So that's why we start with the second one. Now, so index goes from second to upper bound, or to last, and key is assigned my list index. So key is assigned 8 in our example, because index, first value for index would be this, right? Lower bound plus 1, which is 2. Now we assign place to index minus 1. So place would be assigned 1 basically, because we're starting from the second, right? So second minus 1 is 1, so 1 is assigned to place. Now if my list place is greater than key, or in other words, if we have 9 before we have 8, then we execute this while loop. Now what this while loop basically does is that it will go through the array, loop through it, and it will check backwards, like I explained. Basically, this is the part that does that. It checks backwards and checks and compares if the values before our current value are greater. If they are greater, then it will swap them, and if they're less, then it does nothing. Right, so while place is greater than equal to lower bound and my list place is greater than key, this is just checking 9 is greater than 8, and this is just checking that place is not less than lower bound, because if place is less than lower bound, that it is if it's minus 1 or 0 if we're starting from 1, then we will be comparing with something that doesn't exist, a position that doesn't exist in the array, and we'll get an out of bounds error. So that's why we have this as the condition. So we'll put my list plus 1, which happens to be 8 into temp, because remember how place was index minus 1 and index was 2, so place was 1, and at 1 we had 9. So basically 9 is assigned to temp, so temp has 9. Now my list plus 1 will be assigned my list place. And you remember that place was 1, so it had 9. So my list place plus 1 basically is 2. So 2 is assigned 9. So now we have 9 in the first one and 9 in the second one at this stage. Now we decrement place. So place equals to place minus 1. So place was initially 1, and now it becomes minus 1, so it becomes 0. Sorry, place minus place, or 1 minus 1 is 0, right? Our loop ends, and at the end, my list place plus 1, and you put the key there. And if you remember, key was the second element, which was 8, so you put 8 in my list place plus 1. So we had 9 in both places, and now we have place plus 1. Place again was 0 here, right? So if we add 1 to place, that makes it 0 plus 1, so 1, and we had 9 in both places, and this 9 will get swapped with 8 because we had assigned 8 to key, and now we're swapping key with 8, or rather we're swapping that 9 with key, which has the value 8. And then we have next index. So we did this for second value, right? Or the second element in the array. So now we'll go to the third element and we'll compare in the same way. And because this time our lower bound was 1 here, and if we're starting with third, then at the end our lower bound would not go to 0, it would go to 1. So we'll run this loop again and compare with the first value, because we first compared 3 with the second value, and if 2 is the second value or greater than third value, then we put this here, and then we would compare it again with the 1, or with the 1 lower than that, right? So we'll have value of 3 here, and we'll be comparing with 1. So this way we move things around, and we have our current element stored here always in key, and we use temp to move things around. Okay, so I will just go through what happens if we had our third element as 7. So that becomes 8, 9, and then 7, right? So if we had selected 7 as the third one, so lower bound plus 1, or not lower bound plus 1, this was 2 initially, and we went through one iteration. So now this, because of this next index thing, it goes from 2 to 3. So now the value for index is 3, which means key has the value 7. And place as index minus 1 is now not 1, it is 2. So if my list place is greater than key, is it greater than key? Yes, it is, because second had 9, as you remember, so 9 is greater than 7. So then we execute this while loop. And in this while loop, place is greater than lower bound. Yes, it is. What was the value of place? Place is 2, which is greater than lower bound, which we had, in our example, we had set it as 1. Okay, so yeah, and my list place, again, the same condition, and it's 7 or 9 is greater than 7. So my list place plus 1, so temp is assigned 7, right? Because place was now given 2, and 2 plus 1 is 3. So temp is assigned 7. And then my list place plus 1 is assigned my list place. So we'll have 7 in both places. So we had 7 in my list place plus 1. And rather we have 9 in both places. So we have 9 in 2. And now we also have 9 in 3, because my list place plus 1 we assigned my list place. So my list place plus 1 is 3, and this initially had 7, and this had 9. So we're assigning 9 to a place that had 7. So this had 9. And place plus 1, or 3 after that, had 7, and now it's being replaced by 9. I hope that was clear. Now we will move temp back into this place, so my list place. So 3 had 9, and 2 had 9, and 1 had 8. We'll ignore this for now. We'll just concentrate on second and third positions. So temp, as we remember, it had 7, right? And now we're assigning that to my list place. My list place, of course, being the second position, because plus 1, and so place was 2, right? So now place, my list place is assigned 7, or temp. So second becomes 7, third is 9. So these two are now sorted correctly. Now we decrement place again. So 2 minus 1 is 1. So now place has the value 1. Place now has the value 1, because 2 minus 1 is 1. Correct? Because we were at, again to recap, we were at index 3, because we had gone through the first, or rather the second element in our first iteration when we compared 8 and 9, and then we had moved on to the second iteration, which started from the element in the third place, and then we assigned place to index minus 1. So index being 3 minus 1 gave us 2. And now then we decremented at the end of our loop. So place became 2 minus 1 is 1. Now we go back, and place is checked with lower bound. Lower bound in our case, now erase it for clarification. So we were using lower bound as 1. That meant that place, which has the value 1, is greater than equal to 1. So this condition is true. And my list place greater than key. Place at the value 1, and at the value 1 we have 8, and key is 7. So 8 is in fact greater than 7. Both conditions are met, and we execute the loop again. So my list place plus 1 is assigned to temp. So temp is given the value in the second position, which is 7. So temp is now 7. Now mylist place plus 1 is assigned mylist place. So 7 was in second place, correct? And 8 was in the first place. So place had the value 1. So we have 8 being assigned to place plus 1, or the second value. So we have 8 now on both sides. So yeah, we're done to this part. Now in this condition, or this line rather, we have temp being assigned to mylist place. Place, of course, again being 1. So it looks like this right now. And we already done this part, right? So here, now we have place is 1, right? This is equals. So mylist place is assigned temp, and temp had 7. So this changes things, as 1 is now assigned 7, or because 7 was stored in temp, right? And second is not untouched, so now things look like this, and they're sorted. Now we again decrement place. So place had the value 1 this time, right? And if we decrement 1, then we go 1 minus 1 is equals to 0. And because our lower bound was 1 and not 0, because I changed it from the question, right? Now this condition is false. So we will exit the loop. 0 is not greater than 1. Now we exit the loop and while, and mylist place plus 1 is assigned key. So again, key had the value 7. So mylist place plus 1 is now just assigned 7. And place again was decremented again, so it was at 0. 0 plus 1 is 1. And the first position already had 1. So it basically is unchanged. So this if statement ends, and we'll basically loop through an entire array this way and compare backwards. I wouldn't go further because I think this is enough, like, conceptually. So we had 1, 2, and 3. It had this. Now if a fourth position had 6 in it, then we would do the same thing. We'd start with index as 4. Place would have the value 3 at first, and then we'd compare it here, and it will go here, and 9 will go here, and then we'd compare it with 8, and it would go here, 6 would go here, and 8 would go here. And then with 7, and 6 would go here, and 7 would go in the second place. So I hope this part was clear. As mentioned at the start, insertion sort performs better than bubble sort, or it's more efficient, and the reason for that is because it conducts less swaps or less loops. And in this, as the number of elements in a list increases, the time taken to sort the list increases, and as the number of elements increase, the performance of the bubble sort deteriorates faster than the insertion sort. Example, they say that if we had used bubble sort, it made 38 swaps, and if it used insertion sort, then it made 21 swaps. So this basically saves us time. So even though the time complexity for both bubble sort and insertion sort is O(n) squared, because they both have nested loops, right? You have for loop and then while loop. So, and if you just had like one loop, then it would be O(n), and if you had 3 loops, then it would be O(n) cubed. But because it performs less swaps, even though its time complexity is the same, it ends up being more efficient when the number of elements in the list increase. The data type of key is supposed to be integer, not Boolean. This was just a misprint in the textbook. And I will just go do a recap of the algorithm. So at the first place, we had the declaration. So we'll know that we need the upper bound and lower bound, and we need the array, and we also need index to loop through the array. Then we have key as the element that we'll be selecting and comparing against everything, and then we have place, which is what we use to keep track of positions that we're comparing key against, right? So these are the 6 variables that you have to declare. And then in the second part of the algorithm, we set the upper bound and lower bound. And if you want, you don't have to set the lower bound, or you can just hard code this value as and start from 2, or if you're starting from 0 as your lower bound, then you start from 1. So the first 2 parts are done. And now we have the outer loop as the third part. So in the outer loop, we loop through from the second element to the last element. So for index, second element to last element, which happens to be 8 here. And again, we start with index, and the index value is assigned to key, because this is the element that we will be comparing with everything else. And place is assigned index -1, because we'll compare with one position behind the element that we've selected. So if we have selected 2, then we're comparing it with 1. And if my list place, so if the value that's before, if it is greater than key, which was the index value, so we had 2 as the index value. If this is 8 and this is 9, rather, this is 9 and this is 8. So place, which is 1 here, if it's 9, then it's greater than the second value. Then we execute this while loop, which is the fourth part. So the nested while loop. In the nested while loop, we compare place with the lower bound first to check if we're still inside the array, and then we check again to see if this element before the element for the selected element is greater, and if it is, then we swap them. And this is similar to what we did in bubble sort. Basically, the ahead element that's ahead is stored in temp, and the element that is greater is then transferred to the element that was ahead. So now it exists in both those places. And now we want to assign the lower position back the lower element. So we had 9 in both places. So now it would be assigned, because we had camped 8 in temp, so now we would just assign it back. So this whole thing is just us swapping, or these 3 lines rather are just the swap taking place. And then we decrement place, because like I said, we go backwards or compare with previous values, right? And finishing this up, my list place +1 is assigning a key. And then we just close the if condition and close the outer loop. On to the questions. So in the first part, it asks, state 2 factors that may affect the performance of a sorting algorithm. So as you mentioned before, performance refers to like the time taken. And if we increase the number of data items to be sorted, then we decrease the performance. So it is a factor in the performance of the sorting algorithm. And the second is the efficiency of the sorting algorithm itself. So like we explained before, how bubble sort does more swaps, so it's less efficient. So that may also impact the performance of the sorting algorithm. Now in B part, they gave us an algorithm, which is a simple bubble sort that arranges a set of scores stored in a one-dimensional array into descending order, not ascending. So basically just the sign changes from in the bubble sort code. So if it was ascending order, this here would be greater than, and orders the corresponding students' names to be stored in a 2D array in the same order as the scores. Our arrays are indexed from 1. So like in our examples, the lower bound would be 1, not 0. contents of both arrays or after sorting are shown. Right. So I guess this is first name, last name. Anyway, write an algorithm using pseudocode that will perform the same task using an insertion sort. So as I mentioned before, we first had to declare variables, but because they didn't do that in the start and they didn't ask us to do that, then we don't have to do that first step. So we can skip that. Second, we set the lower and upper bounds. Here, instead of using the lower bound and then decrementing it or then incrementing it, we can just hardcode the value as well. So that's what I've done here. So upper bound is 249 and lower bound is 1. 1 plus 1 is 2. So we start with 2. 2 to year size or to the end of the array or max index. Now, in the first part they had done, they just copied these three variables into temp 1, temp 2, temp 3. So first is the score, second is the name of the student, or in this first row, and then temp 3 is name of the student and second column rather. First column and second column. Row and column. Right. Now we have a counter set to student. And if this counter is greater than 1 or greater than the lower bound, and score counter minus 1 is less than temp. So we're basically comparing the score of the previous less than sign here instead of the greater than sign, because again we're sorting in descending order, not ascending order. So this only moves forward if this is less than this, less than the value in temp or the current value. If we compare with our template algorithm, then student is the index and counter is the place value. So while counter is greater than 1, so while counter is in the bounds of the array, it's greater than lower bound, and score counter minus 1 is less than, so the value before counter is less than counter, less than temp 1, right? Then we execute this part and we copy over the less than bits. So if counter had 9, for example, then and we had 7 here, then 7 would copy over here, and instead of 9 will become 7. And the names corresponding to 7, would copy over in this manner. Okay? So name counter 1 is assigned name counter minus 1, 1. Name counter, 2 is assigned name counter minus 1, 2. And now we decrement counter. So both places had 7 now, right? 7 and its corresponding names. But we wanted 9 to be first. So we decrement counter. So instead of 7 being here or the second one, instead of looking at the second one, we now have counter as the first element, first position rather. So it was 2 minus 1 is 1. Now, is counter greater than 1? No, it's not greater than 1, it's equal to 1. So, and score counter minus 1, this just gets ignored because we're not in the bounds of the array, or we're in danger of going out here. So, and while, because again condition is not met, we exit this loop, inner loop, and in the outer loop now we just assign the values back. So initially we had copied 9 and its corresponding names into temp 1, temp 2, and temp 3 respectively. So we'll just copy these back into counter and counter comma 1 and counter comma 2. So now we had, this was the situation before, and after this line applies, then 1 becomes 9, and it also corresponds, its copies rather its corresponding names. So we had 1, 9 and 7, 2. So we have sorted in descending order.